Hello everyone, welcome to this YouTube channel, IBwontcrushyou, and today we're dealing with right-angled triangle trigonometry, and we will go through some problems to make sure that you are familiar with these concepts. Problem 1. A ladder leans against a vertical wall, making an angle of 65 degrees with the ground. The ladder is 4.5 meters long. A. How high up the wall does the ladder reach? So, firstly, let's draw our situation. So, here is our ladder, here is our wall, and in here the ground. The ladder is 4.5 meters long. So this is 4.5. We have also an angle of 65 degrees. So the ladder makes this angle with the ground. So here we have 65 degrees. Here we know that we have a right angle, so 90 degrees. And automatically in here we have 25 degrees because here we have right angle, here we have 65 degrees, so we're left with 25 because the sum has to add up to 180 degrees. So it's like this, and we have to calculate basically this because it's we are asked how high up the wall does the ladder reach. So basically we have to calculate this, and we can calculate it by using, for example, sine rule, or we can also calculate it by using something like SOH, CAH, and TOA. So the first one is sinus and angle, for example, alpha equals opposite over hypotenuse. Cosinus alpha is adjacent over h, so hypotenuse, and tangents is opposite divided by adjacent. Or we can simply use our sine rule from the booklet. So we can try it out by using sine rule. So we take this 4.5, so 4.5 over sinus, and we have to take this angle, so always the length and the angle against this length, so sinus 90 degrees, and we're looking for this length. So here we have x because we don't know this length over sinus of this angle, so sinus 65 degrees. And now we can simply type it into solver and find x. And our answer is 4.08, and of course meters. And now we can also try another way by using one of these formulas in order to solve our problem and check if the answer is the same. However, it has to be, but we can try it out by using one of these formulas. And of course we have this value for sure, and this is the longest length, so it's our hypotenuse. And now we can use this angle. So this length is opposite because it's opposite our angle. So we're left with this, and this is adjacent. So we have this angle, so we will have sinus, cosinus, or tangents of this angle, and we have, of course, h, so hypotenuse 4.5, so we can observe that here we have h and here. So we take this or this. However, we're looking for this x, so opposite, so we can only take sinus. So sinus, and now the angle. We are focusing on 65 degrees, so sinus 65 degrees equals opposite, so we can leave O as opposite, and over 4.5, so our hypotenuse, and we can solve it by typing it into solver, or any other way that you want to. We can also multiply both sides by 4.5 and just type it into our GDC, run mathematics, so 4.5 sinus 65 degrees, and we can check the answer. And O, so opposite as we expected, is 4.08 meters. So the same as in previous way by using sine rule. And B, how far is the foot of the ladder from the wall? So basically we have to calculate this distance, so our adjacent, and once again we can use any way that you want. So we can firstly do it using sine rule. So this, our adjacent, over sinus 25 degrees, and something that we already have, so 4.5 over sinus 90 degrees, like this. And now we have to calculate our adjacent. So the answer is 1.90 meters, and we can also solve it by using, in this case, cosinus, because we have h, so our hypotenuse, and we're looking for a, so for adjacent. So cosinus 65 degrees is adjacent over hypotenuse, so far 4.5, and we can solve it by multiplying this whole equation by 4.5, or by typing it directly into solver. And the answer is the same as from the sine rule. Problem 2. A boat sails 120 meters east, then 80 meters north. A, represent its displacement as a right-angled triangle. So we have to draw our path. So firstly, here we have our starting point. So boat sails 120 meters east, so like this, and this is 120, and then 80 meters north, so a straight line, a vertical straight line, 80 meters. And so we know that here we have a right angle, and here we have our hypotenuse, so we have a right angled triangle, and we have to calculate this distance. So basically we have to use a Pythagorean theorem. So 80 squared plus 120 squared equals x squared. So x is square root of 80 squared plus 120 squared. So x is 144.22, and of course meters. B, find the angle between the boat's displacement and the eastward direction. So this is the boat's displacement, this is eastward direction, so we're looking for this angle. So we can find it by using sine rule or any other formula that applies here. So from our, for example, sinus, cosinus, and tangents from previous problem. However, here we can simply use our sine rule. So we're looking for this. So in here we have 80. So 80 over sinus x equals our 144.22, because we already found it. So 144.22 over, and here we have sinus 90 degrees, and we have to calculate it in solver. So x is 33.69. We can leave it like this for now. And in C, we have to express the boat's bearing measured clockwise from the north. So when we are considering the bearing, we have to start from our starting point. So here is our starting point, and here we have to draw our something to help us to show the north direction. So here we have north, and here we measure our bearing, because we are measuring it in here in clockwise direction. So this is our bearing that we have to calculate. However, we already calculated this bearing. So here is 90 degrees. So all we need to do is just subtract from 90 degrees 33.69 degrees, and this is basically 56.31 degrees. Problem 3. In a rectangle ABCD, AB equals 8 centimeters and AD equals 6 centimeters. Point E, midpoint, is on BC such that triangle ABE is right angled at BA. Find the length of AE. So firstly, let's draw a rectangle A, B, C, and D. So this is our rectangle with its lengths, and when we are given AB 8 here, so here CD is also 8 because our rectangle has opposite sides of the same length, so 6 centimeters in here and in here. And now we have to plot our midpoint E, so maybe in here, and we have right angled triangle. So automatically we have in here 3 centimeters because the midpoint divides our line segment BC into 2 segments of the same length, so 6 divided by 2 is 3. And now we have to calculate AE, so this distance. So basically we can use our Pythagorean theorem. So 3 squared plus 8 squared equals x squared, and we can solve it by using solver, or we can simplify it. So square root of 3 squared plus 8 squared, and now we can calculate it in our GDC. So the answer is 8.54, and of course centimeters. And B, find the measure of angle EAC. So firstly, let's draw what angle we have to specifically calculate. So E, A, and C. So this angle. For now, we know that x, so this side is 8.54. This is what we already calculated. So we have all lengths of our right angle triangle. And we have to calculate alpha. We can use our knowledge that we can firstly calculate, because it's the easiest possible way. Firstly, we can calculate this angle and then subtract this angle. This can be beta and this theta, for example. Because these triangles are right angled. This pink triangle is not, it doesn't have a right angle, so it's a little bit difficult. So firstly, let's focus on this ABC triangle. So what we can do is firstly calculate the length AC, because here we have 8, here we have 6, and we have to calculate maybe not x, maybe y. So 6 squared plus 8 squared, so this both sides, and here our hypotenuse, so it equals y squared, and we have to calculate our y, and it is basically just 10. Okay, so our y is 10, so we know all the sides of this triangle ABC. And now, in order to calculate this angle, we have to use our cosine rule. So it looks like this. We can firstly rewrite it. So cosinus of angle C equals, and here a squared plus b squared minus c squared over 2 times a times b. So cosinus of the angle C, so in our case we can substitute our sine, so beta, so this, and we have to remember that this angle corresponds to this side. So this angle corresponds to the side opposite. So in our case, opposite side is 6, because we were considering this big triangle, so 6 BC is our opposite side. So A is 10 or 8, it doesn't matter whether 8 or 10, because we add up them anyway, so we can start with 8 squared plus 10 squared and minus opposite, so 6 squared over 2 times A and times B, so 10. And now we can calculate it in solver, but make sure that you have in setup degrees, not radians. Or we can simply calculate it in run mathematics by doing something like this. That our angle equals cosinus to the power of -1, and then in bracket our equation, because it's simply this equation divided by cosinus. However, we cannot divide by trigonometric functions, so we multiply it by 1 over cosinus, and 1 over cosinus, in other words, is cosinus to the power of -1, and this is 36.87 degrees. So we already have this greater angle, and now we have to calculate this theta in order to subtract it from beta, and then we will have our alpha. So also in here we have to use cosine rule. So in here we have also 8 as a squared plus b. Here we have 8.54 squared, and of course minus 3, because here we have opposite 3 centimeters as for this smaller triangle. So minus 3 squared over 2 times 8 and times 8.54, and we can calculate it in solver or in run mathematics as you like. And in this, and sorry, here not C, but our angle theta, so our angle equals 20.57 degrees, and now we can subtract, so 36.87 minus 20.57, and it equals 16.3 degrees. Problem 4. A vertical building casts a shadow of 32 meters when the angle of elevation of the sun is 41 degrees. A. Find the height of the building. So let's firstly draw our image. So here we have our building. Let's suppose it's building. Here we have ground. And here we have sun. So like this. So our vertical building casts a shadow of 32 meters. So this is our building, and it casts a shadow of 32 meters. So if our building is this, so a shadow is in here, so 32 meters. And we are also given the angle of elevation of the sun. So angle of elevation is this, because like this is angle of elevation. So we have something in this, we are here and we're looking at it. So this is our angle of elevation, and this is our angle of depression. So for example, when we are here on a plane and we are looking on the ground, so you can remember the shape of, let's call it shape of angle of elevation and of depression. So you can observe that this angle of elevation applies into our image. So this is it. So we can form a right angled triangle. So here we have 90 degrees, and automatically in here we have 49 degrees, because all the angles have to sum up to 180 degrees. So here is 49 degrees, and we have to find the height of the building. So this x is the same as in here, because it's triangle taken from rectangle, so we can find it in this way. And we can of course use for example sine rule, because we're looking for this x. So x over sinus 41 equals, and we have 32 over sinus 49, and we can solve it in solver, and this is 27.8 and meters. And B, later in the day, the building casts a shadow of 12 meters. Find the new angle of elevation of the sun. So once again, we can draw our triangle like this. Of course, the building is still the same. So the length is 27.8 meters. Here we have here we have 12 meters because this is our new shadow of 12 meters. And here we have, of course, 90 degrees, so our right angle, and we're looking for a new angle of elevation. So for this. And now we don't know this side, we don't know this angle, so we cannot apply sine rule. However, we can use something from this. And 27.8 is opposite to this angle, so opposite. So we're considering sinus and tangents. And we also, here is hypotenuse because it's the longest side. So here we're left with adjacent. So we are left with tangents. So tangents of our angle equals opposite, so 27.8 over 12. And now we can calculate it by using solver, or we can type it into our run mathematics like this. And the answer will be the same no matter your solving method is. So our answer is 66.7 degrees. And of course this angle should be greater because I didn't pay much attention to the image, just this length should be longer than this. However, our answer is correct. On the exam you can just draw it according to its length, because then you have to be sure that this angle is this angle is greater than this. So make sure that your image is 100% correct. Problem 5. A ship leaves port P and sails 14 kilometers on a bearing of 70 degrees. It then sails 9 kilometers on a bearing of 160 degrees. A. Represent the journey with a diagram. So let's firstly draw everything what we are given in our comments. So we will start from port P. So for example, in here we have port P, and our ship leaves port P and sails 14 kilometers on a bearing of 70 degrees. So the most important information is that we have to draw a straight line on a bearing of 70 degrees. So when we are considering bearings, firstly we draw a straight line into north, so like this, and then clockwise we have to make a bearing of 70 degrees. Here we know that this is 90 degrees, so let's draw it more or less like this, and here we have 70 degrees, and here we have 14 kilometers. Now we are at this point, so once again we have to we have to draw our north direction, and then next bearing we have the information that then sails 9 kilometers on a bearing of 160 degrees. So directly to the south is 180 degrees, so maybe like this more or less, and here we have 160 degrees. and here 9 kilometers. And of course, we have to connect our starting point and our point at which we are for now, and it looks like this, and that's and here also north, and this is everything for point A, so our journey on a diagram. And in B, use trigonometry to calculate the ship's total displacement from port P. So we have to calculate this distance, this straight line. So we have to use in order to calculate it, because we only know that this distance is 14, this distance is 9 kilometers. We also know these two angles, and now before we use any formula to calculate our total displacement, we have to observe that we can make a triangle in here, like this. So here will be 90 degrees. Here we have 70. So in here we have 20. So something like this. Also, if we were to draw a straight line in here, so this whole has to be 180. So here we have 160. So in here we have 20 degrees. Also, this is 90 degrees, so the rest is 270 degrees. So this everything has to add up to 270. So we're left with 70. And as you can observe, this angle is 70 plus 20. So this is right angle. So we have this angle, and now we can use our formula for cosine rule in order to calculate this orange line segment, so our total displacement. So this is our C, so C squared equals, and now we have to basically it doesn't matter whether 14 or 9 is 8. So for example, 14 squared plus 9 squared minus 2 times 14 plus 9, and cosinus 90 degrees. And we can calculate it in solver, or take the square root of our right hand side, and this is 16.6, and here we have kilometers. So this is our answer for point B. And C, find the bearing of the ship from P. So we are starting in here, our point P. This is north, and here is our ship for now. So we have to calculate this bearing. However, we know that here we have 70, so we're looking only for this angle, and then we have to add these values in order to have a bearing of the ship from P. So here we will also use cosine rule, however the changed one. So cosinus C equals a squared plus b squared minus c squared over 2 times a times b. So now we can substitute our values. So we have to remember that this is always opposite to this side. So firstly, we can also erase this because we already know that this is 16.6. So now we can substitute a 14 squared plus 16.6 squared minus 9 squared over 2 times 14 times 16.6, and we have to calculate it in solver or multiplying it by cosinus to the power of -1. So this is our angle, and this is not the final answer because we have to do one more thing. So 70 plus our answer, so 32.8 degrees equals 102.8 degrees, and this is our final answer. Problem 6. A square-based pyramid has a square base ABCD with side length 10 centimeters and vertex S directly above the center of the base. The height SO equals 12 centimeters, where O is the center of the base. A. Find the length of SA. So let's firstly draw our pyramid because it will be easier to find this length because we will have this square-based pyramid in front of our eyes. So this is our pyramid, and we know that we have to find length of SA. So of this, this is basically a slant height, and we know that we can find it by using Pythagorean theorem. So we need also this height and this. However, we don't know the length of this, so we can firstly redraw our base, and we know that our base is basically a square. So here it has 10 centimeters. Yeah, we have here centimeters, 10 centimeters and 10 centimeters. So we know that when we divide it for 4 little squares, here will be 5, 5, 5, 5, 5, and so on. So this AO is in here. So here we have 5 and here we have 5. So this AO is hypotenuse of our triangle with sides 5 and 5. So firstly, let's find it from Pythagorean theorem. So let's denote it as x. So 5 squared plus 5 squared equals x squared. So our x is 7.07. So this is our AO, so 7.07. And now we can find our AS or SA from Pythagorean theorem. So we have 12 squared plus 7.07 squared equals, we can denote it as SA squared in bracket because this is our SA, so it works like the whole value, so in a bracket and squared. And this is our SA is 13.9 centimeters. B. Calculate the angle between the line SA and the base ABCD. So we have to calculate this angle. So let's redraw our triangle. So something like this. Here we have O, here we have our vertex, here we have A. We know that SA is 14.9. Here we know that AO is 7.07 and height is 12. And we have to calculate this angle. Here we have a right angle. So now we can use, for example, sine rule in order to calculate this angle. So 12 over sinus alpha equals 13.9 over sinus 90. and we have to calculate our alpha, and we took this side because we have an angle opposite to it, and here we are looking for alpha, so this side, and we don't know this angle, so 7.07 is useless. And the answer is 59.7 degrees. And C, find the angle between two slant edges SA and SB. So we have to find this angle between this line and this line, because these are our slant edges, so we're looking for this angle. So we can once again redraw our triangle, but this time the other triangle. So here we have S, here we have A, here we have B. We know that here we have 10, so it stays the same. Here SA, we know that SA is 13.9, so 13.9 in here, and here the same value, because we know that this is square-based pyramid, so the slant heights are the same. So this is our triangle, and we have to calculate this angle. So now we have to think what we can do to find this angle. Obviously, when we don't have right angle triangle, we can divide this triangle into two smaller. So let's suppose they are the same, because on my image they are not, but they have to be, so they are the same. So here they have right angle. So here we have another points, not points, angles, but we know that this is 5, this is 13.9, and we have to calculate our height from the Pythagorean theorem. So here we have height, so height squared plus 5 squared equals 13.9 squared. So height, our h, equals 13.0 centimeters. So our height in here. And now we can use, for example, sine rule to calculate this angle. So we have 5, so this side and opposite angle, so 5 over sinus angle equals, and we have this side, so 14.9 over our right angle, so sinus 90 degrees. So this is 25.1 degrees, and of course we have to add this to theta's, so our final answer is 42.2 degrees. And that was the last problem from this right-angled triangle trigonometry. And if you found this video helpful and useful, you can leave thumbs up, subscribe to my channel, and in case of any questions or any doubts, you can write them down below in comments or via my mail, that is as always in the description of the video, and in the description there is a little info about a contest.